Hi, this is Purti Kottan and Prasanna Nayak, and this is a screencast for examining static code analysis, which is part of our midterm project for software engineering. So first, let us discuss what is static code analysis. Static code analysis is the analysis of computer programs that is performed without actually executing the programs, usually by using an automated tool. How do we use static code analysis? Is it effective for open source software? This is discussed by a paper called Securing Open Source Code via Static Analysis by Raghudeep Kannavara. In the paper, he applies the static analysis tools to the Linux kernel and finds bugs in this manner. The paper, after analyzing the results of the bugs found, presents a manner in which the bugs can be found better. The standard practice, as we see, is that the open source code is included late in the bug finding process. After the static analysis tool is run on the source code, on the corrected output we include the open source software usually. What the paper says that we should do is that we should incorporate the open source code right at the beginning. This way both the source code and the open source code is bundled together and the runtime run of the static analysis tool is done. So basically open source code is incorporated in commercial software is not subjected to the same stringent static analysis and review as newly developed proprietary code. This is because it is included at the very end, as seen here. An alternate workflow that is proposed is that the static code analysis output for both newly developed and adopted open source should be included right at the beginning. This workflow will subject the open source code to stringent code analysis and review process along with newly developed proprietary code. Any software bug found by static analysis is fixed in both open source and newly developed code before it is subjected to dynamic analysis and well before it is eventually released into the marketplace. There are n number of codes available on the market. Each of the different languages have associated static analysis tools. It is a very hard job for the programmer or any tester or any other developer to find out what static tool to use for the code that they're implementing. One easy way to find this out is by using certain benchmarks. Based on what the user is developing, if we take the benchmarks associated with it, we can find certain static code analysis tools for it. A paper called A User-Centric Benchmark Suite for C Code Static Analyzer proposes a benchmark for C Code static analyzers to aid programmers in picking the most appropriate tools. The benchmark provides quantitative and qualitative measurements for evaluating analyzers. The proposed benchmark is an interesting approach because it concentrates more on the user's requirement than on improvements to the bug detection techniques. In this slide, we see that the benchmark framework for the proposed system. The test case database collects some C program that contains some known bugs, and the type and location of the bugs is also known. The harness is basically an automated framework that helps in evaluation. The evaluation metrics are things that include things like suitability, precision, recall, time over, etc. For example, precision is the rate of found bugs over all the bugs, and recall is the rate of write alarms over all the alarms. Suitability is to know whether the analyzer will parse all the code in the program successfully. The sorting capability, a good analyzer would be able to sort its alarms, making the most likely correct and most serious alarms in the front to have high priority to be removed. So this way, there are several benchmark standards by which tools can be checked. Splint, for example, has a less suitability compared to flaw finder, Uno, and CPP check. These four are static analysis tools for C code. Here we can see that there is a graph which shows all the bugs and the true positives as found by Splint and CPP check. As we can see, all the bugs and the true positives are here the same way for each of the times, and they're used for different run times and different code standards. Thank you.